The name of our project, well, we'll go into the team and the data in a second, but name, I think, is just interesting because it sets the precedent for the context of our analysis. So we primarily did a social network analysis for determining athletic superiority. By athletic superiority, we kind of twisted the words here because really I just wanted to end up with this SNAFDAS, which is sad fans inversed, and you'll see why. But the essence really is that we used geospatial, so physical coordinate data, and categorical marks, so descriptive data, to come up with a predictive model that we would hope could help football teams prevent future embarrassment on the field. And sad fans, yeah. So our team, I'm Lionel Jonas, by the way. You could say I'm the storyteller. I don't know. I don't have a data science background. I have a physics background and then mostly marketing. So I helped a little with the data visualization, and now I'm making up my portion of the project now.
So I'm Enrico, and during this project I've mostly been working on the social network analysis. I've been having just a very brief look into the data science and machine learning, but very, very brief. And then I was also developing the visualization together with Massimo.
Hi, I'm Massimo Nicchinelli. Well, I'm a designer, but basically I also split a bit between specifically visualization and creating the app, and also a bit of network analysis and integrating all the efforts together in one application.
And Andrea, who couldn't be here, really took the lead on the data science and machine learning portion, which is unfortunately why we can explain the overview and what he's communicated to us, but really the expertise on that is missing today. So you can Skype him later. Okay, what's the point of the presentation? So thank you to deltatre for really giving us a lot of flexibility on what we analyzed. They had a number of suggestions for what we could look at, but really they left it up to us. And so we thought of a number of different ways and almost pursued 3 different analyses with 3 different end results, and ended up cutting it down to 2, and really what we ended up with was 1.5. But really, here's the point. When you watch a sports match, what makes it entertaining? Is it seeing your team win or seeing a close match? And you know, it's really in the benefit of the league to have an even matches. It draws viewers. Really, you know, you see highlights when the TV switches screens to a different match. It's when the match is close. So, and in these professional leagues, these top-tier teams should be somewhat equal. We didn't find that to be the case in the one match that we were presented. So what we'd like to do is, rather than having leagues that are full of 7-0 matches like this one, we want to make it a little bit more even. We want to give the underdogs the ability to analyze why they were cut like butter, why they were so destroyed, demolished, and how they can improve their performance in future matches, both by giving coaches the ability to reposition their players, by giving broadcasters general managers the ability to identify individual contributors. So really those 2 things that we looked at were passing routines, patterns, tactical strategies on an individual team, and then the actual individuals themselves and what contribution they have to the greater match. So the data that we were provided was fairly robust for one match, but that was the limiting factor, was that it was one match. We received a 740 kilobyte file in XML format with really 2 components that were of interest. 2 components of the data set at all. The XY coordinates of every single object on the field at any moment in time. I think it was two moments per second. Every second we had 2 data points for everything from the ball to the referee to every single player as well as the goalpost. So we were able to actually, in our initial presentation, we should have included this, but the little dots that we could see the players moving on the pitch just by creating an object that was a circle and playing that over the course of the field. So we had geospatial coordinates. We had categorical descriptions which were predetermined by deltatre. So that included any touch, which could be a pass, a block, defense, a goal, shots, both long and short. It was a very robust number of marks and just very descriptive information. The problems with the data, really there were three, two of which could be very easily resolved in the future. One that was not, we didn't find it to be as much of an issue as we initially thought. So the sample size, you know, when you're limited to one match, you're limited to the number of goals, the number of big opportunities, the number of passes that occur in that match. You know, when we were now analyzing individual player performance, it was difficult to separate between the individual player and the position, for example. So you only have two forwards, either on a team or two teams, maybe four, depends on the strategy they take. But you have a really limited sample size, so take that into account. Also, this match was, it was a 7-0 match. So it really was an outlier. Those don't happen too frequently in the top tier leagues. In any league, well, maybe high school. And then lastly, the tracking errors. As we did that initial visualization showing the objects moving around the field, we did notice some players and even the ball hopping across the field. Ball is less surprising, but players can't really hop across the field in 1 second. So there were some minor glitches, but it didn't impact the overall analysis that we ended up doing. We didn't try to focus on the tracking errors. We focused on the social network analysis and a predictive model. So, do you want to talk about predictive? Or? Yeah.
So when it comes to the, when we got the data, we sort of take a little bit of a brainstorm, and then we tried to come up like with some ideas what to do with the data. And in particular, there were like two main lines of thoughts. One was actually to build some predictive models, and in particular when it comes to the predictive models, we were thinking of two different kind of predictive models. One predictive models which tells you when a highlight is about to appear, which can actually be very, very good. Imagine that you're actually doing something else and you're connected with a number of matches or just one particular match. You would like to have an alert when a highlight is about to happen. So that was one possible predictive model that we could have done. Another predictive model which could have been interesting was, as Lionel mentioned, sometimes like the players in the tracking, they disappear, or also the ball disappears, they reappear somewhere else. So and this has to do how the players are tracked with cameras. And for instance, after a tackle, it can happen that one of the players disappears or is mistracked. And so one of the things could have also been to look at when a player is more likely to disappear. So for instance, when it gets very close to another player, so that could have been one thing. The other part was also looking at the social network, because after all, football is and should be a team sport. So interaction between different players is really crucial. So we felt that it was like a very good spot to actually start to do a little bit of a social network analysis, pretty much like Facebook social network or Twitter. But with this data. Difference here, unlike Facebook, is the fact that you have both good interaction and bad interaction. So there are like a lot of players that they are interacting with the opposite team because they are getting the balls or they are tackling them a lot. So we felt it was a quite interesting spot, and also to see whether like from this from the social network analysis, we could have found a correlation and also like interesting patterns between the teams, in particular like the social network, to actually see whether there are some patterns which recurs very frequently. So that's more or less what we were focusing on. And when it comes to the tools, so the predictive model they were developed in Python. Actually, I just have to say one thing, because our initial goal was very, very ambitious, especially for the predictive models. And in the end, we decided, when it comes to the predictive model, we decided to focus on the highlight. And when it comes to the highlight, for instance, one can actually look at how the players are placed in the field and what happened in 1 minute or 2 minutes before. But at the status of art, Andrea managed to build a model which was able to look at the highlights only on the position of the different players on the pitch. So it built so it was looking at building like some tensors, and it was like a fairly complicated algorithm, but which pretty much what it does, it just assigns the different players to different zones, and then it tries to estimate how likely a highlight is about to happen, depending on the players, where the players are, as well as where the ball and the referee. The referee is probably less important, yes. But most of really what we really pushed a lot was more the social network analysis, and in particular we initially used Neo4j in order to store a graph database. However, the number of samples, the number of data we had, if you imagine, all right, Facebook, million people, a match, very few. So as Adam was pointing out before, we felt that in this case we could have implemented everything like with a very good framework, but it was not really needed. So in the end, we actually used mostly Network X, which is a Python library. And then we've been also doing a little bit of data mining with Gephi, in particular for visualizations. And in the end, we developed like a visualization platform, which we are about to show with D3. And another thing that's very interesting is also like we started to actually look at the most central points, so where most of the play goes through, and all the different communities that they create. So for instance, the defense can be a community, and the defense together with the attacker can be a community. So, yeah, go ahead. So maybe it's actually time to show a little bit the final result. So we created a sort of a dashboard which allows a kind of simple query of the data, as well as in particular for the social network to really look at why one team was so superior to the other one. And in particular is meant to be very user-friendly. So at first you're given like a number of options that you can choose from. And so for instance, now we can actually like look at the network of both teams, so which will include both good interactions and bad interactions. And another thing, you can actually like just sub-select part of the match where you are more into looking which kind of interaction there has been in that particular part of the match. And by the way, you actually see that there's been really a lot of goals. Actually, probably there was like one event during the match which really signed the match quite a bit, which was a red card at the 3rd minute. And so you can actually just sub-select one part of the match, and then you can see a little bit the overview, how the different players were displaced, and then you can actually see which one were the most common patterns. This one is just for one pass, so the most common pattern was just, which included just one particular pass was that one, but we can actually include more passes, and then see which were the most played patterns. And so this is an example. So this one was very strong, so this team kept on, actually this one was the winning team in the end, kept on passing the ball in this way. And by the way, this is just a visualization, static visualization, but what might have happened a lot was actually that the 27 or something was actually going in this direction. So it was like, if you're a football player, you see this player that is going like on the side, and then it puts like the ball in the middle. So that could be one thing. Then you can also, I think, sub-select one player and see what were the most common patterns for that particular player. Oh. Murphy's Law? Okay. And then you can actually see which were the most common patterns that that particular player was involved. So that's, oh yeah, maybe with a little bit more passes, maybe. Yes. And then, as I said, one of the things is also looking at the social network, pretty much like on Facebook. And maybe we can go down to see the network. So, which tells you how much the different players were interconnected among each other. And you can also modify the size of the player depending on how important those players were for the match. So, in particular, who does interact the most? There was a little bit of a bug, damn it, of course. Okay, no, it works, 5 minutes, all right. And you see actually one very interesting thing. The 44 is very big, all right? Is one of the players that is interacting a lot and is from the losing team. It's not the goalkeeper. The goalkeeper is actually the 30. It could have been actually there. But the 44, what does that mean? It means that it was most likely the player which was losing most of the balls. So it was one of the one that did not perform quite right, because most of these connections, they are now within the team, but with the other team. And you actually see it from this. And so you should not buy, if you have a football team, you should not really buy the 44, I guess, or at least given this match. And then there we can also, so in this, we actually realized that like a bunch of features that one can actually look at the data, also like what are like the most central points, the one where, this one is very cool, is also the different communities. So as I was saying before, like Fender with attacker might be a community. And here in particular, we show the different players to which community they belong, depending on the color. And so I think it was a very cool visualization to have. And and then of course, as I was saying, you can actually change a little bit the time frame. Now I wanted maybe to spend. This one was also like another thing we did was to, given this social network analysis, also like to try to come up with how good a player was. Okay, very quickly. So here actually like we have all the different players. The turnover is like one very particular point, which is how many balls you got from the other team to how many balls minus how many balls you've been losing. So if you are in this negative side, it means that you've been losing more balls than what you actually got. And I think here there are some very interesting things to see. First of all, these two players from the winning team, they actually lost a lot of balls, but they still perform fairly well. So, I mean, here you've got the turnover. This is like a measure for the social network analysis. And actually, the size of these blobs are proportional to, a sort of score for how good the player was. But you see that those two guys, 7 and 9, were actually quite good, but they've been losing really a lot of balls, though. And there is also another interesting point, which is always the 44, the one that is... I'm not high enough, but it's like the point uppermost, which has a very strong betweenness. Once again, it's very similar to what we were seeing before. The fact that is one of the most connected person, but a fairly negative turnover, which is nevertheless a little bit higher than this 9 and 7, a little bit surprising. And and also a fairly high degree of betweenness. And one of the things also from this graph is the fact that you can actually also look and find patterns for different players in different part of the pitch. So, for instance, these guys, they are probably defender because they get more balls than they lose. This one, they are of course attackers. So once again, from this, you get a little bit of a clustering depending on the position and on their role. And just very quickly, then you can actually like do also like a subquery for just one particular team, and then show just the network for that particular team. So now there is not the interaction between the other team anymore. So the 44 would just be very small now, and you can see the communities. And the very last thing before closing up is also that you can actually, like one of the things that we were also looking is what was the position, the area of most interactions, so where they were most present. and also the network for one particular player. So that's a little bit of a dashboard which one can really play and really query the data and enjoy the social network analysis. And with this, I think we can close it, also because we are running out of time. And we've Oh yeah, just because it's very important also the process. In any project, it's very important the process. So let me just show you a little bit of an overview of the entire process. That's right, we had 3 weeks, but most of it, if you see at the date, actually happened in the last week. So these are the commits to in GitHub. So so okay, now starts to appear something. Okay. And then, you see, we're working also on Saturday and Sunday, great. And then you will also see like the final rush, pretty much until last night at 4 o'clock in the morning, so more or less this. And I think it's a very, very good visualization of the entire process. Thanks to Massimo, which really did a great job with this. And that's pretty much right now. All right, thanks a lot for the help.